Welcome back, focused learners, to this explainer. Today, we're diving into a concept that is absolutely crucial for taking your C++ code to the next level. We are finally moving away from those rigid, totally predictable programs and stepping into the dynamic world of input and output. We're going to trace the exact journey of a piece of data as it flows directly from the user deep into your computer's memory and then right back out onto the screen. This is a fundamental building block of literally all software development, and once you master this, it's really going to change how you approach programming.
So when you first start learning to code, it's super common to write what we call hard-coded logic. You can kind of think of it like a padlock that only has one single combination. Say you write a program where A equals 10 and B equals 20, and you tell the computer to add them together. I mean, it works, sure, but it's only ever going to calculate 10 plus 20. It's frustratingly rigid. Dynamic programming, on the other hand, acts a lot more like a funnel. It actually asks the user at runtime, hey, enter a value for A. And what this means is that every single time you run the program, you can process entirely new information. This is where your code actually becomes powerful, and it perfectly highlights why we need to communicate with the user while the program is actively running.
To really wrap our heads around how this works in code, just think about a standard physical computer setup. If you had a computer with no keyboard and no monitor, it would be, well, completely useless, right? It relies totally on input devices to get instructions and output devices to actually show you the results. Our programming logic is exactly the same. The code we write requires a dedicated internal system to handle the data flowing in and the data flowing out. The hardware relies on physical wires, but our code relies on specific C++ commands to build this bridge between the user and the processor.
Okay, so to build that bridge for data coming in, we use a really vital command called sin, which stands for console input. You can honestly think of sin as the ultimate traffic director for your program. It just stands at the gateway, paying incredibly close attention to the keyboard. Whenever the user presses a key and hits enter, sin is the command that actively captures those keystrokes and pulls that raw data straight into your application. Without it, your program is basically deaf to anything the user is trying to tell it.
Now, on the flip side of that, we have cout, which stands for console output. So if sin is listening to the keyboard, cout is doing the talking to the monitor. This is your outward-facing command. Once your program has taken in the data, crunched all the numbers, and generated a result, it needs a way to show its work, right? Well, cout takes that internal logic and effectively pushes it straight onto the user's screen. It's exactly how your program communicates its final answers to the outside world.
But here is the crucial catch. Before we can actually accept any of that input, we have to prepare a place to put it. Imagine someone tossing a baseball to you. If you don't hold your hands out to catch it, it just drops straight to the floor. In C++, we catch data by declaring a variable. Writing a command like string name tells the computer to carve out and reserve a very specific, dedicated container in its memory. We're labeling that container name, and right now it's just sitting there, completely empty, patiently waiting for incoming data.
Now that we have our empty container ready to go, let's actually ask the user for some data. We write cout, enter your name. Let's break this down real quick. We start with our output command, cout. Then we use those two less than signs. We call that the insertion operator. You can picture this operator acting like a funnel, taking whatever comes after it and pushing it toward the console. Finally, we have our text, wrapped in double quotes. Because it's in quotes, the compiler knows to print that exact phrase as a simple string, giving the user a clear instruction so they know exactly what to do.
So the user reads that prompt and types their name. To catch what they just typed, we use the command sin into name. Notice how the arrows have completely flipped. Those two greater than signs form the extraction operator. While sin captures the raw keystrokes, the extraction operator essentially reaches in, pulls that data out of the input stream, and aims it directly into that waiting memory space we just allocated, our variable called name. That empty container is now officially holding the user's data.
Now pay close attention, because here is a highly specific technical concept that comes up in coding interviews all the time. When the user types their name and hits enter, that data does not instantly teleport directly into your variable. No way. There's actually a hidden middle step. First, the data is typed. Second, it is captured and held in a temporary internal waiting room known as a buffer. It's only after it is safely secured in that buffer that it finally gets moved into your allocated variable space. So remember, it's a three-step journey, not a two-step jump.
To really nail this concept, we need to know exactly where this buffer lives in the actual computer hardware. Because this temporary waiting room isn't just floating around in the digital ether. The buffer is physically located in your system's RAM or random access memory. Interviewers love to try and trick you here.
They'll ask if this input buffer is stored in the CPU's super-fast cache memory, or maybe inside the system registers. The definitive answer is absolutely not. It is strictly a temporary storage area allocated within standard system RAM. Understanding how your code connects to the physical hardware like this is exactly what makes you a standout programmer.
All right, let's bring this all back to the code. We successfully asked for the data, the user typed it, it's safely passed through the RAM buffer, and now it's sitting inside our name variable. Now it's time to display our dynamic result. We write cout tconsult hello tconsult name. Look at how we're using that insertion operator twice in a single line here. First, we funnel the hard-coded string hello to the screen. Then right next to it, we funnel the actual contents of our variable. The compiler is completely smart enough to combine the standard text with our newly populated dynamic memory space.
And boom, this is the final culmination of our entire data journey. If the user typed Varun into the keyboard, the monitor is going to flawlessly display Hello Varun. Our program isn't stuck adding 10 and 20 together anymore. It's interactive. It's responsive. By mastering just these few fundamental lines of code involving variables, sin, and cout, you've just unlocked the ability to create customized, user-centric software that adapts on the fly.
But hey, understanding the theory just isn't enough. You've got to get your hands dirty and put your fingers on the keyboard. So I have a practical assignment for you. I want you to build a mini biodata program. It needs to prompt the user for 3 consecutive separate inputs: their name, their address, and their phone number. You're going to need to allocate 3 separate variables. Use sin 3 times to capture the data flowing through the RAM buffer. And finally, use cout to cleanly print all 3 pieces of information back out to the output screen. It's absolutely the best way to cement these concepts in your brain.
Before we wrap up this explainer, I want to leave you with a really fascinating puzzle to test your new knowledge. Imagine you run your brand new program, and when it asks for your name, you type your full name with a space in the middle. Say, for example, Varun Singla. Think very carefully about how sin and the extraction operator actually function under the hood. When you tell it to print the variable, what will it actually output to the monitor? Will it successfully capture and print the entire string Varun Singla? Will it cut off right at the space and just print Varun? Or will that space cause a complete error and print nothing at all? I highly encourage you to open up your compiler, write the code, and find out for yourself exactly how C++ handles spaces and data streams. Thanks for joining me today, and happy coding.
Welcome to Start Studying. Don't forget to like and subscribe.